Hello class, today we're going to learn about the cosine law and how we can use it to solve for angles and triangles. So now we're going to run into scenarios where we have non-right angled triangles and we have 3 side lengths, but we don't know any of the angles. So how do we solve for at least one of those angles? So far we've learned that the cosine law, the formula for it for when we're solving for a side length, is written as c squared equals a squared plus b squared minus 2ab cos of the angle c. Now you have to recall that this formula was derived when we have a non-right angle triangle and we are given 2 sides and the angle between it. So for example, the way it's written in this formula, we know the side length of A and the side length of B, and we know the angle between it, which is the angle C. And by using these 3 information, we can plug into this formula to solve for the side length C, which is over here. But now we're asked what happens if we have a triangle and we don't have the angle C. And so now we're given the same similar triangle, A, B, C, but instead we're going to have the side length A, B, and C, and that's all we know. So now we want to solve for possibly the unknown angle C over here. Okay, so we're trying to solve for this value. So we're going to use the same formula of cosine law, but now we're going to just rearrange it to solve for the angle that we want, which is over here. Okay, so this is just a matter of rearranging the equation. So if we're trying to rearrange the equation so we can isolate for the angle, because we have everything else, we have all these other side lengths, then we have to remove everything around that variable. So the first thing you want to remove is anything of the addition and subtraction, right? So it's the opposite of BEDMAS we want to remove first. So we're not going to get rid of these things first because these are all being multiplied. These are being added and subtracted to the angle C. So we're going to get rid of it by moving it to the other side. So when we do that, we're going to end up with c squared minus a squared minus b squared. And then on the right side of the equal sign, we'll have negative 2ab cos c. I just moved the formula above just so that we're lining up our equal sign. So as you can see here, I've moved the a squared and the b squared to the other side, so it's over here now. And now what we want to do is, again, isolate for that variable of the angle C. So now we have to get rid of anything that's being multiplied with it. Well, the things that are being multiplied with it are the a, b, and the number negative 2. So we're going to divide it out. So we're going to divide it negative 2ab. But we do to one side, we've got to do it to the other side. So divide by negative 2ab. So now our equation looks like this. C squared minus a squared minus b squared all over negative 2ab equals cos c. Now remember, the reason why I haven't divided out cos is because it's not a number. Remember, cos is a function, it's an operation. So therefore, I can't divide it out. So now, to isolate for the actual variable c, remember we have to get rid of that cos. And to get rid of it, we have to use because cos is an operation, we have to use the opposite operation, or cos inverse. So to get rid of it, we'll have to use the cos inverse. What you do to one side, you must do to the other side. So now the equation will look like this. Cos inverse of the left side, which is all in brackets, c squared minus a squared minus b squared all over negative 2ab, and then you would actually apply the cos inverse of that answer. So that way it will give us the value of c. If you want to see it rewritten the other way, most of the time you'd see the formula written as the angle c equals cos inverse of c squared minus a squared minus b squared all over negative 2ab. So this is the formula for cosine when you're solving for the angle of C. It looks more complicated than the other formula that we know. You're more than welcome to just use the side length version of it and then isolate for C after you've plugged in all the values. But let's use an example so you can see how it's actually applied. So let's just review about the cosine law. So a reminder that we use the cosine law when we have 3 sides and you want to find the angle. That's what we're doing in this scenario. Last time we were given 2 sides and the angle between, and we wanted to solve for the 3rd side. Okay? So just refreshing when we can use cosine law in general. But let's now apply it to an example. Here we have a triangle ABC. And as you can see, we have 3 side lengths that are known. Let's label the sides appropriately. So this would be A, because it's across from the angle A. This would be B, and this would be C. So now we want to determine the angle A. So in the formula I've written above for you, we were solving for the angle C. And so that's okay if we now have to change it to a different letter, for example, in this case, A. But what has to match is if you look at the formula, the angle C is over here and the side length C is over here. And what's really important is that the angle that you're trying to calculate, the side length is the one that's positive in the formula and the other side lengths are negative. Well, they are being subtracted. So you have to, when you rewrite it for a different letter, make sure that you match it so that the angle and the side length are the positive version here, okay? So let's write that out for this one. So the formula for angle A would look like this. A equals cos inverse, bracket, side A squared minus, and then it doesn't matter if you do B squared minus C squared. It doesn't matter if I write minus C squared and then minus B squared. What matters most is that the angle A and the side length A are the first things, okay? And then we're being divided by negative 2BC. So the letters here, B and C, are the ones that are repeated in the denominator as well. And then close bracket. So now that you have the right formula, you just plug in what you need, what you have, and then therefore calculate what you need. So in this case, A equals the cos inverse of, in bracket, the A side length A is value of 8 squared minus 9 squared minus 10 squared all over negative 2 times B, which is 9, times C, which is 10. And this is where I would just plug it all in your calculator. I'd first make sure that you plug in what's inside the bracket first, and then do the cos inverse. If you're following along by calculating it with your calculator, make sure you calculate the 8 squared minus 9 squared minus 10 squared first. Then when you divide, make sure you put this in brackets, the denominator in brackets. That way you're doing the answer divided by, in brackets, negative 2 times 9 times 10, and the bracket, so that you're getting this answer divided by this answer, okay? So this all should calculate to actually equally cos inverse of 0.65. It terminates to a nice number like that. And then you would take your calculator and make sure you do the cos inverse of that answer, which now leads you to an approximate value for the angle A to be 49.46 degrees, but we're going to round that to the nearest whole degree, so A ends up being just 49 degrees. Okay? And that's how you use the cosine law to measure for an angle. I just want to say, recap all that we've learned so far. So when you're trying to decide which ratio to use, this is a flowchart that might help you distinguish what to use. So the first question you always ask yourself when you're given any sort of triangle, is it a right angle triangle? Okay, if it's a right angle triangle, meaning it has that 90 degrees down there, then you're going to use ratio, okay? So sine ratio, cos ratio, and tangent ratio, like SOHCAHTOA. Although sometimes with a right angle triangle, you don't even need these ratios. Maybe you're just looking for the side lengths. And then you would use Pythagorean theorem, okay? But as we've been learning, not all triangles are right angle triangles. So if it's a no for a right angle triangle, then you have to ask yourself, do you have a matching pair? That's what this question is asking you for. Is there a matching pair of a side length and an angle? And that really is the distinguishing factor between using the sine law when you have a matching pair. And if you don't have a matching pair, then you use this cosine rule, okay? And then for both sine law, I know it says rule, but for both sine law and cosine law, you can solve for an angle or a side length for both of these. Okay, so you can solve for the angle or the side length. But what distinguishes using one over the other is there a matching pair? Because if there's a matching pair, use the sine law. If there isn't, then use the cosine rule. Okay, so just to summarize, we use the cosine law to find an angle or a side length. This is a different version. You might see this version of the cosine law. The reason this is different from the one I showed you is that it still has the cos on the left side. So you could do that, and that's still allowed. And then just remember to get rid of that cos by using the cos inverse of the answer you get on the right side. Okay. The other formula over here was the old cosine law, which is used to solve for a side length. Okay, so this one is used to find the side length, and the right side formula is used to find an angle. All right, so good luck and have fun with cosine law.